Hi, I'm Martin, and in this Nexperia video series we will show best practices on how to place ESD protection devices on a PCB. To better understand the reasons for best ESD protection placement, let's look at a typical system. On the left side is a connector where the ESD pulse enters the signal line. Next to it is our ESD protection component. Further down the signal line is the IC that is to be protected. The IC will in most cases have an internal ESD protection, but that is usually just strong enough to let the IC survive manufacturing in an ESD-controlled environment. To make the system survive real-world ESD stress, it needs to be optimized. This means that as much of the ESD pulse should be discharged at the ESD protection component at the connector, and as little as possible should go to the IC. In other words, the residual current that goes past the ESD protection should be minimized. Knowing that the current of the ESD pulse always takes a path of least resistance, the system can be optimized by reducing the resistance of the ESD protection component and, if possible, increasing the resistance on the signal line to the IC. In practical terms, this leads to the following guidelines. Firstly, it's good practice to place the ESD protection component as close as possible to the entry point of the pulse, the connector, and as far as possible to the IC. This helps discharge the pulse as quickly as possible after it enters the system and helps increase the resistance of the path between protection and the IC. Secondly, the ESD protection should always have a good ground connection. By keeping the connection to ground short, by using wide PCB traces and multiple vias, the resistance on the discharge path through the ESD protection is minimized. When connecting to a ground layer, it is important to verify if the connection to the design ground point is as direct as possible and not obstructed by any other signal or interruptions of the ground layer. Thirdly, stubs should be avoided when connecting the protection component to the signal line. This would add unnecessary resistance to the discharge path through the ESD protection and make it easier for more current to flow past the protection. Another way to optimize the system, that may be available in some cases, is adding resistance to the signal line behind the protection. Already 1 or 2 ohm may help improve the system-level ESD performance in critical cases. This is of course only possible if the signal performance and the impedance of the signal line allows it. Finally, the choice of the right ESD protection component is equally important to optimize the system. We will explain how to find a protection that matches the internal protection of an IC in another video. Thanks for watching. I hope this video was useful for you.